In the lesson 6.5 example, are these peanuts underweight? We're going to do probabilities involving X bar, or sample means. At the Peanutty Peanut Company, dry roasted shelled peanuts are placed in jars labeled 16 ounces by a machine. The distribution of weights in the jars is approximately normal with a mean of 16.1 ounces and a standard deviation of 0.15 ounces. We want to know what the probability is that the mean weight of 10 randomly selected jars is less than the advertised weight of 16 ounces. So the first thing we need to do is identify the variables that we're going to use in this problem. In this case, X bar is the sample mean weight of the 10 selected jars. And we want to know some properties of X bar. The mean of X bar, that is the mean of all the sample mean weights of 10 selected jars, is going to be the mean of all the jars put together, which is 16.1 ounces. The standard deviation of the sample mean weights of the jars is going to be the standard deviation of the population over the square root of the sample size. So in this case, 0.15 over the square root of 10, which gives us 0.047 ounces. And as for the shape of the distribution of X bar, we know that the shape of the distribution of X bar is approximately normal because it said in the problem the population distribution is approximately normal. That is, each jar is filled according to a normal distribution, which means that these sample mean weights will also follow a normal distribution. So we can draw a normal distribution that shows the sample mean weights. And we show that the mean is at 16.1 and the standard deviation is 0.047. So we can mark off 1, 2, and 3 standard deviations in each direction. We want to know what the probability is that we end up with something 16 or less. So 16 is very close to this number, just slightly less than that number. Right there, there's 16. We want to know what the probability is that the sample mean weight in ounces is less than 16, so this area over here. We're going to find the z-score for that number, which is negative 2.13. And using table A, we can find the probability that z is less than negative 2.13 is 0.0166. So there's between a 1 and 2% chance that if you select 10 jars at random, that the average weight of the 10 jars in your sample will be lower than the advertised weight of 16 ounces. If you'd like to try a problem like this in your book, you can try exercise 9 in this section.